Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss another problem. So let me give the problem first, then we will discuss the solution. I hope you are enjoying these problems. So today's problem goes like this. I will use this color. You brake your car from a velocity of 85 kilometer per hour to 45 kilometer per hour over a distance of 105 meter. Part A, what is the acceleration assuming it to be constant over the interval. Then we have another part B, how much time elapses during this interval. Then we have part C, if you were to continue braking with the same acceleration, how much longer would it take for you to stop and and how much and here additional distance would you cover? Would you cover? Before going to the solution, try to understand the problem. Let me check the problem first. You brake your car from a velocity of 85 kilometer per hour to 45 kilometer per hour over a distance of 105 meter. Part A, what is the acceleration? Assuming it to be constant over the interval, how much time elapses during this interval? If you were to continue braking with the same acceleration, how much longer would it take for you to stop, and how much additional distance would you cover? You can see this is motion in a straight line situation, and we are given that acceleration we can assume to be constant. So we can use equations of motion for constant acceleration. So first we are moving at this 85 kilometer per hour speed. Then we begin braking and reduce this speed to 45 kilometer per hour. Then during this process, we move 105 meter forward. We are asked to find the acceleration and the time which elapses during this process. And in part C, we are asked to find how much longer would it take for us to stop. That means first we reduce speed from 85 kilometer per hour to 45 kilometer per hour. Then we continue braking until we stop the car. In that process, that means in the process of reducing the speed from 45 kilometer per hour to speed zero, we are asked in part C to find that time which is required for that process and the additional distance which we move. So let us move to the solution. So first we have to decide our positive direction. First we take the part A. So let us first select the positive direction to be the direction of the velocity. Direction of the velocity. So we take the positive direction of our x-axis to be the direction of the velocity. And what we do, we choose the origin so that x naught is 0. So I will draw a diagram. The situation is like this. This is our car. It's moving to the right. So this is my x-axis. And this is my positive direction in the direction of velocity. So I take, let me use another color. I take origin here where I begin braking the car. So it's going at this moment which becomes my initial velocity at 85 kilometer per hour. When I begin braking, I write here plus 85 kilometer per hour. That means it's moving at speed 85 kilometer per hour to the right. And this moment when we begin braking, we designate it as t equals 0. Right? When we begin braking, then I will use this red color. Our car reaches to position and velocity v, that becomes our final velocity for this process, which is plus 45 kilometer per hour. Plus means it is still going to the right, but at a lesser speed. And during this process, it moves 105 meters. 105 meters. So this displacement from this point to this point is 105 meter. Try to understand it. Car is going to the right. I am beginning braking. That moment I am labeling t equal to 0. It's going at 85 kilometer per hour speed. When I begin braking, then it reaches the speed of 45 kilometer per hour. Plus means it is going to the right, and this is my initial position, which I take the origin. So my x naught is 0. During this process, the car travels 105 meter. Oh, now we are asked in part A to find the acceleration, right? So to find the acceleration, we need an equation which does not involve time, because in my data, my final velocity, initial velocity, and displacement is given. So I will use this equation using v square is equal to v naught square plus 2a x minus x naught. Let me use this color. So we will make use of this equation to solve for acceleration. Now from this equation, when you solve for acceleration, it will be v square minus v naught square over twice x minus x naught. V square minus v naught square over twice x minus x naught. So let us put the numbers. My final velocity in this part of the problem is 45 kilometer per hour. So I put it 45 kilometer per hour. I square it minus my initial velocity is the velocity when I begin braking. That is my 85 kilometer per hour. Then I have square. So 45 kilometer per hour square minus 85 kilometer per hour square. Then I have twice the displacement. My displacement is x naught is 0. So what is x? That is my x minus x naught, which is 105 meter, or I will write it in kilometers, which is 0.105 kilometer. I have converted it to kilometer. You know, 1 kilometer is just 10 raised to 3,000 meters. Using that, 105 meter is 0.105 kilometer. So let us solve for A, and when you solve for it, this A is minus 2.48 into 10 raised power 4 kilometer per hour square, which is also minus 1.91 meter per second square. As always, so this is the answer of part A. As always, you need to check it at home. The simple, you have to solve these numbers. When you solve these numbers, you will get your acceleration in kilometer per hour square, and in kilometer per hour square, you get the value minus 2.48 into 10 raised by 4. And when you convert it into meter per second square, you get it minus 1.91 meter per second square. So it is, first you have to check whether you get this number, then you have to check whether it gets converted into meter per second square and gives this number, right? You can see acceleration comes out to be negative, which means it is opposite to the direction we choose to be positive. That means acceleration is directed this way. Because our positive direction is to the right, acceleration turns out to be negative. That means it is opposite to the direction which we choose to be positive, that is opposite to the direction of motion. Let us move to part B, which says how much time elapses during this interval. So let us move to part B. Now, in part B, we use which equation? The equation which does not include acceleration and permits us to find the time from the original data. And that equation is this. So using x is equal to x naught plus half v naught plus v times t. X is equal to x naught plus half v naught plus v times t. Remember, in the last problem, we discussed the 5 equations of motion. 2 are made and 3 are obtained when we eliminate different variables, right? This is one of them. You can check in the last lecture also. So when I solve for time in this equation, what I get? Time is twice x minus x naught over v naught plus v, right? First you take this x naught to left hand side, it becomes x minus x naught, then it becomes twice x minus x naught. When you take this 2 to your left hand side, then this v naught plus v comes in the denominator. So time is 2 times x minus x naught over v naught plus v. So let us put the numbers. X minus x naught is, first it is 2, x naught is 0, so x minus x naught is just x, which is 105 meter, but we put it in kilometers, which is 0.105 kilometer. 0.105 kilometer. Let us put the numbers. My initial velocity is 85 kilometer per hour, plus my final velocity is 45 kilometer per hour. So when I make the calculation, what I get, it gives me 1.6062 into 10 raised power minus 3 hours, which is also 5.8 second. So this is my answer for part B, time lapsed during the process. So it is, when you make the calculation, you will get time in hours. So you get 1.62 into 10 raised power minus 3 hour. When you convert that to seconds, you get 5.8 seconds. Remember, 1 hour is 3600 second. As always, you need to check it at home, check the calculation. So this is the time which elapses in bringing this car from 85 kilometer per hour speed to 45 kilometer per hour speed. Now let us move to part C. Right? In part C, we know the acceleration. What we see time for car to go from 85 kilometer per hour to zero speed, right? Let me first modify my problem, my figure. After this question says if I continue braking, I reach, let me use some other color, this one. Maybe here, this car comes to rest. This is at rest. So its speed there is 0. Now what we do, we're asked to find in the part C assume acceleration is same, how much it would take longer for you to stop, and how much additional distance would you cover? We'll go this way. We will first find, using this equation, v minus v naught by a. You know v is v naught plus at. It is one of the equations. So if I use this equation, I solve for t. My t is v minus v naught by a. So what we do, we take final velocity 0 and initial velocity 85 kilometer per hour. That means I find time when I stop the car between this moment and when I begin the brake. So my initial velocity is 85 kilometer per hour and my final velocity is 0. I find time for that process. Time beginning from the point when I begin braking to time when the car comes to halt, it stops, using this equation. So what is my final velocity then? Final velocity is 0 and my initial velocity is 85 kilometer per hour, and I divide it by the acceleration because it is given that acceleration is assumed to be the same, which is minus 2.48 into 10 raised power 4 kilometer per hour square. So when I solve it, it is 3.43 into 10 raised power minus 3 hours, which is 12.3 second. So let me encircle it. As always, check the calculation, check it at home. See, my final velocity is 0, my initial velocity is 85 kilometer per hour, and I have substituted for a minus 2.48 into 10 to the 4 kilometer per hour square. So I will get, when I do the calculation, my time 3.43 into 10 to the minus 3 in hours, and when I convert that into time, the seconds, I get 12.3 second time. Now, this time is the time required for the car to stop, beginning from speed 85 kilometer per hour. But question asks us what additional time elapses from the time car is going at 45 kilometers. I am asked to find the time from which elapses between v is equal to 0 and v is equal to 45 kilometer per hour time. So I have calculated the total time. Therefore, the required time can be obtained by subtracting the time required for 85 kilometer per hour to 45 kilometer per hour time. I can subtract that time from the total time. Now see, the car comes to stop after we begin braking, 12.3 seconds after we begin braking. That is required answer. I call that T prime is 12.3 second minus 5.8 second, which is 6.5 second. This is my answer for part C. Because 12.3 second is the total time beginning from 85 kilometer per hour speed to 0 speed. And as we know, 5.8 second is the time required for the car to come from 85 kilometer per hour to 45 kilometer per hour speed. So the additional time which is required for the car to come to rest from 45 kilometer per hour to 0 speed is just 6.5 seconds. This is my answer for part C, first portion. So we subtract 5.8 second from 12.3 second. So we get our answer as 6.5 second. So the car comes to stop 12.3 second after you begin braking, or 6.5 second after it reaches the velocity of 45 kilometer per hour. Now to find the distance, we will use x minus x naught is v square minus v naught square by 2a. We are using v square is v naught square plus 2a x minus x naught. This is the equation. So from this equation, I solve for x minus x naught, which is v square minus v naught square over 2a. So I substitute v is my 0 and my v naught is 85 kilometer per hour square. Then 2a is my minus 2.48 into 10 raised power 4 kilometer per square. Let me change the color. When you make the calculation, it is 0.146 kilometer. As always, check it at home. C, x minus x naught is v square minus v naught square by 2a. I am putting v as 0, v naught as 85 kilometer per hour. Then I square, then I have 2 times the acceleration, which is minus 2.48 into 10 is 4 kilometer per hour square. And when I solve, I get 0.146 kilometer, or in meters, I can write 146 meter. 146 meter is 0.146 kilometer. Which distance is it? It is distance, this distance. From this moment to this moment when I stop, this whole distance is 146 meter, because I am putting final velocity as 0 and initial velocity at 85 kilometer per hour, right? So this 146 meter is this distance, but I am asked to find the distance which I move from 45 kilometer per hour speed to speed 0. So it's easy. I can subtract 105 meter distance from that. So let us do. The additional distance traveled between the point at which v is 45 kilometer per hour and the point at which v is 0 is additional distance is 146 meter minus 105 meter is 41 meter. Don't get confused. This is additional distance. By additional distance, I mean it is the distance traveled between the point at which velocity is 45 kilometer per hour and the point at which v is 0. So it is 146 meter minus 105 meter, which is 41 meter. That means this distance in the figure is 41 meters. Simple. This whole distance we have calculated 146 meter. Then we subtracted this distance 105, so we got 41 meter. I hope you got the problem. So first we calculated acceleration, then we calculated time lapsed, then we calculated the additional time lapsed and additional distance moved from the point where speed was 45 kilometer per hour to the point where speed is 0. Think about these problems and check all the calculations at home. I hope you're enjoying solving these problems, and don't forget to like, share, and subscribe my channel. You can comment in the comment box. Thank you. God bless you. Assalamu alaikum.